Hello, in this video, what we're going to talk about are vectors, and we're going to talk about three specific things. What is a vector? How do you add vectors graphically? And then how can you take a vector and break it into components using trigonometry? Hopefully this will help you complete your assignment on vectors. First of all, what are the content language objectives? The content objective, I can add vectors graphically. Content objective, I can resolve or break down vectors into x and y components using trigonometry. And then the language objective is I can explain to another student how to add vectors graphically. So first, what are vectors? Vector basics up at the top here, it says we use arrows to represent vectors because vectors have two things. They have magnitude or size and direction, the way that they point. And so vector quantities would include things like velocity. Velocity is not just speed, it's speed with direction. And so the size of an arrow tells you the magnitude of a vector, the length of an arrow, and then the direction it points, the angle that it's pointing at is the direction. And so first off, how do you add vectors graphically? Adding vectors graphically, what that means is if you have two different vectors, how do you put them together and figure out what your result is? The result of adding them together, we are going to call a resultant, and it's going to be shown by a double line. And so first of all, adding vectors, there are two different sides of a vector. I call the side with the arrow the tip of the vector. The side without the arrow, I call the tail. And so what you do when you add vectors, the order, it says up here, does not matter. You are going to add them, though, tail to tip. And so you are going to add the tail of your second vector to the tip of your first. And so if you start with vector 1 here, you can draw out the vector. You are going to add the tail of vector 2 to the tip of vector 1, and then draw that vector in the same direction with the same length as you have indicated here with vector 2. When you are finished adding however many vectors you have together, you will then draw an arrow from the very start of your arrows from your vectors to the very end of your arrows. And if you draw a double line from the original tail to the final tip, that is what is called your resultant vector. And so again, that's graphically adding vectors. The overall start to finish is called your resultant. The second thing that you can do with vectors is you can resolve vectors into x and y components. And so if you have a vector that's shown over here, 40 meters, and then it is in a specific direction, 30 degrees, north of east, I guess, if that makes any sense. You have an angle and you have a resultant. And then what you can do is you can use your geometry skills, SOHCAHTOA. We'll go over that in just a minute, but SO stands for sine is equal to opposite over hypotenuse. CAH, C-A-H, is the cosine is equal to adjacent over hypotenuse. And then you can use, using degrees in a calculator, those trigonomic functions to figure out if you have a resultant, what would be the x, or the horizontal, and the y, the vertical components of that vector. Going down to some examples. There is some vocabulary you can go through in a little bit, but one main thing you need to do is to be able to add vectors graphically. The way that you would do that is, again, adding vectors tail to tip. And so if we tackle problem number 10 here, for example, it says you have vector 3. And so I would draw vector 3. It doesn't matter the order. I'm trying my best to get them the right size and the right direction. Plus 2v4. V4 is shown right over here. You would add the tail of vector 4 to the tip of vector 3 that was drawn here. Since you have two of them, you are literally going to add the vector twice. And then one part we haven't talked about yet, when you subtract a vector, if you subtract v5, it's the same thing as adding the opposite of it. So it's like adding that vector, but you have flipped the direction that the arrow is pointing. And so if I have, again, vector 3 plus 2 of vector 4, and then this is negative v5, what I end up with is something that looks like this. And the last part that you would need to take care of if you're adding vectors graphically is you need to draw in a resultant. And so your resultant goes from the original tail to the final tip. You would draw using a double arrow. And again, mine looks terrible, but that would be your resultant over your overall vector from the very beginning to the very end. The last thing, we've talked about what a vector is. You can review that with the vocabulary up here. We've shown one example of adding vectors graphically. The last thing is, how do you resolve vectors into their components using trigonometry? And so just to spell it out across the bottom, again, we don't need to worry about the TOA, but the trigonomic functions are SO and then KA. We don't need TOA because we're not dealing with that. We'll just ignore it. But SO stands for sine. The sine function is equal to opposite over hypotenuse. And so when we're talking a triangle, there are three different sides of a right triangle. There's an opposite side, an adjacent side, and a hypotenuse. The hypotenuse is the long one. It's the one that's opposite of the right triangle. And so this would be your hypotenuse, the 42. Your opposite side is going to be opposite, not touching the angle that's given to you. So this would be our opposite side. And then our adjacent means next to. It's the side that's not the hypotenuse that's touching the angle here. And so we're going to use sine is opposite divided by hypotenuse. And then cosine, ca stands for cosine, is equal to adjacent. Again, that's next to divided by, hypotenuse. And so we don't need the whole tangent function because whenever we resolve vectors, we're going to have the hypotenuse that's involved somehow. And so how do you do these trigonomic functions? How do you take care of these? What you're going to do is, again, pretend that your vector is a triangle, and you're going to use your geometry knowledge, geometry background to solve. And so you can solve for the opposite side, the side that is not touching the angle, by using the sine function, because sine of your angle, 35, is equal to opposite over hypotenuse. So sine opposite over hypotenuse. So sine 35 is equal to opposite divided by our hypotenuse, which is 42 meters per second. I'm just going to ignore it for now. And so when you try to resolve this, you can multiply each side of the equation by 42 to get rid of this in the denominator. 42 times sine of 35 is going to give you your opposite side, what the magnitude of your opposite side is. And so that would be the y value for this problem. You could type that in your calculator. Just make sure that you are in degrees and not radians. Otherwise, you'll come up with an incorrect answer. And so if you are trying to figure out what the adjacent side would be, you would use the cosine function, because cosine is equal to adjacent over hypotenuse. C-A-H, cosine, is adjacent divided by hypotenuse. And so cosine of 35 is equal to adjacent over 42. Again, multiplying each side by 42 to get rid of your denominator here and solve for adjacent. 42 times cosine 35 is going to give you your x value. So that's all I've got for today. Again, we went over three things. What is a vector? It has magnitude and direction. It's an arrow. The size is your magnitude. Which way it's pointing is your direction. We talked about how you can add vectors graphically, adding them tail to tip. Your resultant is the overall from start to finish. And then we just talked about how you can resolve a vector into its x and y components using trigonometry. If you have any questions, please stop by the homework help office hours. If you have any questions, you're welcome to email as well. Thank you very much. Have a great day.